Okay, welcome back everyone. Today we're gonna learn about logs. So, logs are trees. They're just kidding. Okay, now we're talking about the math log. Okay, so let's get rid of this. In terms of math, logs means logarithms. So logarithms. Okay, logarithms. They are the inverse of exponents. So I'm sure we've all learned exponents, but if you haven't, when we say, let's give an example, 2 exponent 3, that means you multiply 2 by itself 3 times, okay? 3 times. Now, logs are the inverse of this. So the way you write a log is first put a log, and then you put the base. This is called the base. You put a number here, so let's say 10. Then you put another number here, right? Let's say 100. This is the general format of a log. So this part equates to this part. Now, how do we evaluate this expression? So what this means is that it's asking 10 raised to the what power equals 100. Well, let's see, 10 raised to, let's say, first power, that's 10. That's 10 is not 100. 10 to the second power, oh, that's 100, right? So the answer is going to be 2. So in some way, this is the answer to an exponent question. This is the base to an exponent question. So this 10 here, that's the base. And this is the exponent, okay? So let's do an example. So let's say 5 to the third power is 125. Now write this in log form. Well, we know the base is 5, right? So log base 5. And this is where the answer is. So 125. So 5 raised to what power is 125? Well, we've said it here. 5 raised to the third power is 125. So the answer is 3. Okay. And now we're gonna transform this. We're now gonna transform a log to an exponent. So let's say the log of log base 2. And by the way, the way how you say it is log base whatever number this is, and you just say this number. So log base 5 125 equals 3. Log base 10 100. And sometimes if you don't say the base, it's just 10. So if you do like log 1000, that's just 3. You take it as log base 10, okay? So log base 2 of 8, that's 3. Okay, so then let me get rid of this. So then how do we write this in exponent form? Well, you just move this here. The way how I like to think about it is you move this here and you push this 3 up. So 2 to power 3 equals 8. They are equivalent expressions. Okay. So now let's do some logarithm rules. Log rules. So similar to exponent rules, for example, n to the a times n power b, that's n to exponent of a plus b. So this is just an exponent rules. For the log rule, equivalent to this is log n a plus log n b equal to log n a times b. Okay, so for example, log let's do log 6, no sorry, log 2 6 plus log 2 let's do what can we do? Let's do 5.4. No, wait, sorry. Not 5.4. Point. Okay, I'll just write it this way. 32 divided by 6. So, what is what is this expression gonna be? Well, do we know what log 26 is? 2 to the 2 is 4, 2 to the 3 is 8. We don't know exactly what it is. Do we know what this is? Well, it's a fraction, so it's going to be very difficult for us to figure it out. So then this is where we can use logarithm rules, okay? This is equivalent to log 2 times 6 multiplied by 32 over 2. That's just log 232, right? Log 232. And we know what this is. 2 to the 5 is 32. So this is 5. So this equation, the answer to this is 5, right? Okay. So similarly, another rule is log NA minus log NB equals to log NA divided by B. And sorry if my writing is very, very messy because I'm using a mouse. Yeah. So we can similarly do something like this. Log 6 log base 2 64 minus log base 2 32. Now we can solve this without using the logarithm rule. So this is just 8 minus, oh wait, sorry, this is 6 minus 5, so that's just 1. But we can also use the logarithm rule. So log this equals to log 2 64 over 32, which is log 2 of 2, which is 1, okay? Alright, so we've got the basics covered now. Another rule, which should be quite intuitive if you mastered exponents, is log base n to the 1, that's 0. Because why? Because n, okay, so this is just 1 equals n to the power 0, and we know this is true, right? Anything to the power of 0 is 1 except for 0. So where n does not equal to 0. Alright. Okay, so this is the third logarithm rule. The fourth logarithm rule is log base n a to the b. Now, the reason I'm writing n here is because it's very generalized. You can write pretty much, you can substitute any values for n in, so it's very generalized, okay? So this is equal to b times log n of a. I'm not gonna do any proving in this video. I can do proving in the future, like perhaps next video if you guys want me to do a proof. But I'm just gonna list the rules here for now because the proving is a little bit more advanced. And so what this is just that if a to the power of b, you can just move b here. So log n base n a to the power of b, that's just b times log n a. This is much easier and in a much better form because multiplication is usually preferred over exponents, right? Okay, so let's do an example. Log 2 of 2 to the power 4. Well, 2 to the power 4 is 16, so this is just 4. 2 to the power 4 is 16, right? Or we can also do it like this. You move this here. 4 log base 2 equals 4 times 1 equals 4. Much better, much neater, and just much more preferred, right? So this is a pretty cool rule. And lastly, we have rule 5. This rule is slightly more advanced. I had a difficult time learning this. Took me longer to figure out, but this rule is called the change of base. So what this is log n of a. Now, what if we want to change the base of this? We don't want it to be n. We want it to be something else. So in that case, what we would do is we would actually take this. So the base, let's say the base we want is b. We move a here. Log ba divided by log bn. So I usually just like to think about it as you draw a line here. Oh, whoops. You draw a line here. Log b this, top, log b this, bottom. So yeah, that's how I remember it. And this could be useful in various problems. So if you have something like log mm, log say 3 to the 8, then this you want to change it to log 2. This could just be log 2 of 8 divided by log 2 of 3. And note that we know what this is. It's just 3. So the answer is just 3 over log 2, 3. Right? And we can just approximate this. There's actually a very famous problem that lets you approximate the log base 2 of 3 is. And you have to do like all sorts of stuff, but we're not going to do that in this video. Similarly, I guess you could also turn the denominator into an integer, but yeah, I'll let you do it as an exercise on your own. So that's the basics of logs for now, and if you have any more questions, please link it in the comments below, and there will be future videos on logs. So if you don't understand everything, that's okay. We will be covering logs in the future as well. Thanks for watching.